Hello and welcome to this video on multiplying radical expressions. Alright, so in this video we'll see some radical expressions involving the radical symbols, roots, right, square roots, cube roots, and so on, and multiplying them as though we are multiplying polynomials. Right, I'll start off by explaining what I mean by that, and then we'll get into several examples. Okay. So a couple things you're going to need to remember for this video is how to multiply polynomials. So let's get into that. All right. So for example, remember when I multiplied, let's do a couple of these, if I had like a monomial like 2x, so a polynomial with one term, and I was multiplying that, right? Notice the no plus or minus here. It's implied to be, they're touching, it's multiplication. And then, multiplied by a binomial, something with two terms, say 3x minus 4. I mean, used the distributive property in this case, right? You took the only term from this polynomial and then distributed it to all the terms from the other one. And then, there were some properties of exponents that I'm not really going to get into. Hopefully remember them. 2x times 3x, right, would be 6 times x to the second, 6x squared. And then the 2x times the negative 4 would be negative 8x. Another example, that was a monomial times a binomial. How about the product of two binomials, say 5x minus 1 multiplied by x squared plus 3 or something, right? Two terms in this polynomial times two terms in this polynomial, and the same principle held. You picked one of them and then you distributed every term from the one you chose to all the terms in the other one. So I would start off with the 5x and distribute the 5x to the x squared plus 3. All right, that would give me 5x times x squared would be 5 times x to the third power. 5x times the positive 3 would be positive 15x for the next term. And then I'd be done with the 5x in the polynomial I chose. Then I'd move over to the negative 1, the next term, and distribute that and create more terms in the final result. Negative 1 times x squared would be minus x squared or negative x squared, and negative 1 times positive 3 would be negative 3. And there you go. And very often they'd say we'll write it in descending order, so the 5x cubed first, then the negative x squared term, then the positive 15x term, then the negative 3, right? But still, you took every term from one polynomial and distributed those terms to the other polynomial. And then if you had to, there's nothing to do here, but if you had to, you would then combine like terms. And then one more example of this, where say I had a two-term polynomial, x plus 1. Let's go x plus 3. Why not? Multiplied by, and then a trinomial, like a three-term polynomial, x squared minus 3x plus 4. Right. Same thing. I am multiplying two polynomials. I pick one of them. Say I choose this one, the x plus 3. That's got two terms. You're going to distribute each of these two terms to the other three-term polynomial. So I'll start with the x, right, and distribute the x, right, to all three terms of the other polynomial, creating three terms in my product, right? X times the x squared would be x cubed. X times the negative 3x would be negative 3x squared. And then the x times the positive 4 would be positive 4x. And then I'm done with the x in this polynomial I chose. Then I move to the next term, right, the positive 3, and distribute that to the other polynomial. Right? So you just take every term from one polynomial and distribute it to the other polynomial. and then combine like terms afterwards. So the 3, 3 times x squared would be positive 3x squared. All right, and I'm just, because I don't have a lot of room here, I'm going to put it down here, positive 3x squared. And the positive 3 times the next term, the negative 3x, be negative 9x for the next term in the polynomials, the product. And then 3 times 4, positive 12. And then combining some like terms, the terms both with x squared or both with x here, we get x to the third as the first term. There's no x squareds in this example, right? The negative 3x squared and positive 3x squared would add to be 0 x squared. And then the 4x minus the 9x would be minus 5x, and then you have the positive 12 on its own, and there you go, right? So hopefully remember multiplying polynomials. Those examples look familiar. Where you just, when you're multiplying two polynomials, let's say it one more time. When you're multiplying two polynomials like this, you pick one, and then you take every term from that one you chose, distribute it to the other one, and then, combine like terms when you're done. All right. So want you to remember how to do that. And one other thing you should remember as well is the product property for radicals. All right, so one other thing you should be recalling here from a previous video or previous lessons, the product property for radicals. And I've put this up in several videos in the past. So look up, using the product property for radicals to simplify, or using the product property to simplify radical expressions, something like that. Remember what that states. That's the, if you take an nth root of some radicand a, some number a, and multiply it by the nth root of b, you'll get the something that's equivalent to the nth root of a times b. And you can take the product of, it's a product though. Notice there's no adding or subtracting here. It's a product. All right. Now this doesn't always work though. Right? This is only true as long as the nth root of a and at the same time the nth root of b are real numbers. All right, this is a property of real numbers, okay? So if you're taking even roots, right, you can't have negative radicands, right? You can't have negative numbers inside square roots or fourth roots or sixth roots because those are not going to be real numbers. You're not going to get a real number result, all right? All right, so hopefully that rings a bell as well, as a nice refresher because that's going to be used. One other thing to point out here too is notice that the index of the radicals throughout this property is always the same. It's always an index of n, so they're all square roots or all cube roots or all fourth roots, etc. Alright, so just keep that in mind as well. Great. Alright, so what we're going to do here is, for all the examples I have in this video with the radicals, I'm going to be asked to do the following: multiply, and of course simplify, right? Simplify the radicals. I'll talk about that also. What did that mean, right? I've mentioned simplifying radicals in previous videos. All right. So this example, we have the square root of 6 multiplied by the quantity. And there's no plus or minus here, right? It's multiplication. And then the other factor has two terms, 3 minus, and then the 5 times the square root of 6, or 3 plus negative 5 root 6. So again, you multiply as with polynomials, as I did in that first page. So you see how this is a one-term expression multiplied by a two-term expression. So you're using the distributive property here, right? Just distributing this one term to these two terms. So the first term, when you take the square root of 6 times 3, those are simply the factors. It's 3 times the square root of 6 for the first term. All right, notice, I'm not making this like the square root of 18 or anything. All right, I know that 3 times 6 is 18, but remember that product rule that I just wrote up. You can only use the product rule if they're both square roots or they're both cube roots, and they're not, right? These are not. This 3 is not inside a square root, so I can't make that the square root of 18. It's just simply 3 times the square root of 6. Then minus, and then I have 5 times the square root of 6, right, that term, and then times the square root of 6 again, right? So another factor of the square root of 6. So I've multiplied, and now we got to simplify. Now this is where the properties come in, right? I can use the product property on this square root of 6 times square root of 6, right? I can use that product property on that product. All right, so the first term, I have 3 times the square root of 6, or just 3 times, square root of 6 without the dot. Then minus, and then I have 5 times, and then this square root of 6 times square root of 6, right? They're both square roots of non-negative numbers, so they're both real. I can use the product property, and that'll be the square root of 6 times 6. Or, you could write 6 squared in here if you want to make it easy. But what is the square root of 36? That's just 6. All right, the square root of 36 is just 6. Because remember, whenever you see this symbol with an even root, you're asked for the non-negative square root. So yeah, I know negative 6 squared is also 36, but they're asking for the positive one here, the non-negative one. All right, so writing that in, we have first term, 3 times the square root of 6. And then the second term has a negative 5 times, and then the square root of 36, the non-negative square root of 36, is 6. And finally, our terms are, 3 times the square root of 6 is the first term, and then negative 5 times 6, negative 30 for the second term. And notice you can't put these together, all right? These are not like radicals. This has a square root of 6 attached. This term does not. Just like terms, you cannot put these together and make like negative 27 root 6 or anything like that. So this is as simple as that will get. And of course, I like to, you know me, right? You've seen videos of mine hopefully before. I like to, for these radicals anyway, pull out a calculator and check. Is what I started with actually equal to what I ended up with, right? So let's take that original expression. I had the square root of 6 times, and then in parentheses, 3 minus 5 times the square root of 6. So there's the original expression I had on my calculator. Getting some crazy, number with decimal, probably an irrational number with, decimal that goes on forever without ending or repeating. That's negative 22.65153077, blah, 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 right? And keep going. All right. So hopefully what I put in this box down here has the same value. All right, let's see. 3 times the square root of 6 for the first term. Then after that, minus 30. Oh, and look at that. They are the same value, this negative 22.65 something. Great. All right. Looks good. Alright, and that's all I'm going to be doing. This whole rest of the video, these examples, is multiplying and simplifying whenever possible. Okay. So here, this example, I have the cube root of 12. So just another expression with one term, just the cube root of 12 times, right? Times and then parentheses, this expression with two terms. 3 and negative cube root of 12, cube root of 2. So again, I'm using distributive property, taking this, this one term here, distributing it to these two. So this is equal to, well, the first product, you have, the first term, you have 3 times the cube root of 12, and I'll write it exactly like that, 3 times the cube root of 12. Because again, the 3 is not in a cube root. This isn't a cube root times a cube root. It's just 3 times the cube root of 12. Don't make this the cube root of like 36. All right. Just leave it like this. They're not in the same roots. Can't use that product property. Then we have minus, and then I have the cube root of 2 times the cube root of 12, right? That gets distributed to it. And here I can use the product property, right, with the product of these two cube roots. I'll write that again. Now, this will be the last time I probably write it. I'll just say it. Oh, product property. That's how emphatic I was. Product. Say it twice, but you can use the product property here. All right. So again, the first term, nothing to do really. Got 3 times the cube root of 12, and then minus, and then these two I can actually multiply together. These are both real numbers, right? And this will be the cube root of 2 times 12 is 24. All right. Now these are not like radicals. Right? This has the cube root of 12. This term has the cube root of 24. So I can't put these together. So you could leave it like this right now, but we are asked to simplify. So off to the side here, don't forget we also have to simplify the radicals when we're done. And hopefully you remember how this is done. Right? I've done this in previous videos as well. So the cube root of 12, 12, when you break it down completely, is 2 squared times 3. And notice none of these factors, none of these bases are raised to powers that are 3 or higher. So the cube root of 12, can't be simplified. There's no perfect cube. Right, we're doing cube root. There's no perfect cube, perfect third power that goes into 12 evenly. So that's already simple. All right, that's already simplified. But the other one, right, that's this radical. How about the other one? The cube root of 24. Well, when you break down 24 completely, that's 8 times 3, 2 cubed times 3. Well, or you could just write 8. But there's a perfect cube, right? We can break this up into a perfect cube times not a perfect cube. Right? 2 to the third, 3 to the first. And then using the product property, right, you can split this up to the cube root of 2 cubed, or the cube root of 8, times, and then the cube root of 3. And what is the cube root of 8, or the cube root of 2 cubed? That's just 2 times the cube root of 3, right? So I can actually simplify this second term a little more. So the first term, we couldn't do anything, right? The cube root of 12 is already as simple as it gets. So that first term is still made up of the factors 3 times the cube root of 12. It's the second one that's different that I'm going to change. The cube root of 24 can actually be rewritten as the factors, 2 times the cube root of 3. All right. And again, these still are not like radicals. Right, this has a different radicand than this one, cube root of 12 on that term, cube root of 3 on this term. So you cannot put these together. Right? I did that last video on adding and subtracting radical expressions. So this is as simple as it gets right here. I put it in a box. I'm done. I have multiplied and I have simplified all my radicals. And that's it. I'm finished. Now again, you know me. I like to double check. I'm going to use my calculator here, and let's see that the expression I started with, is that indeed equal to the expression I ended with. All right, so the expression I started with, I have the cube root of 12. All right, there's the cube root of 12 times, and then in parentheses, 3 minus the cube root of 2. All right, and this gives me the number 3.98378615 and so on. All right, 3.98 something. All right, well, hopefully if I did everything right, the expression I got at the end, that's again simplified, can't be added together, no parentheses. Hopefully that expression at the end has the same value, but better. Right? So that's 3 times the cube root of 12. All right, then after that, minus 2 times the cube root of 3. And look at that, it is indeed the same number, 3.983786315, and so on. Wonderful. Okay, next example. Now the last two, we had a single term multiplied by two terms and had to distribute just that one term. So here's an example where I have two two-term expressions, right? This first expression has, two terms, the 2 and then the -7 times the square root of 3, multiplied by, and then another expression with two terms, the 5 and then the +4 times the square root of 3. Alright, so just as before, on the first page, we multiply these as if we were multiplying polynomials. So I pick one of them, this one here, and then take each of these terms, the 2 and the -7 times the square root of 3, we'll distribute each of those to the other polynomial, the other expression. All right, and I'll write out these terms of the product as we go along. So the first one I have, 2 times 5. Now I know what that is. I'm not going to write out 2 times 5. 2 times 5 is 10. All right, and then we have the next term will be 2 times, that's +2 times +4 root 3. So that'll be positive, right? It's a positive times a positive. And then the 2 times the 4 I can do because those aren't in square roots, right? I can't multiply by the square root of 3 though. That's in a square root. You can't multiply, square roots with non-square roots. So the 2 times the 4 will be 8. And then you have still times the square root of 3, right? So 2 times 4 times square root of 3, that's 8 square root of 3. Great. So I'm done distributing the 2. And then I just move to the next term. The next term is, don't forget, the negative is part of it. And I distribute the -7 times the square root of 3. All right. So the next term, I have -7 times the square root of 3 times +5. So it's negative times positive, that'll be a negative term. Then you have 7 times 5 times root 3. Well, 7 times 5 I can do, those aren't in roots. 7 times 5 is 35. But then you have also this factor of, times the square root of 3. Right. Okay. And then lastly, negative times positive, right? -7 root 3, -7 times the square root of 3, times +4 times the square root of 3. So that'll be a negative result, right? Negative times positive. And if you rearrange the factors, you can have the 7 times the 4, 28, times, and then the square root of 3 times the square root of 3, which you can use the product rule for. That'll be the square root of 9. Right? That's the square root of 3 times the square root of 3. So here's the 7 times the 4. Here's the square root of 3 times the square root of 3. That's multiplying all these factors here. Right? The -7 root 3 times +4 root 3. Root 3. Right? And then, of course, we simplify, combining like radicals and simplifying any radicals that need simplifying. All right, so this is equal to, this first term is still 10. These two terms have like radicals, right? They both have the square root of 3 attached to them. So remember, you could factor that out, and then all you'll be doing after factoring out the square root of 3 is combining 8 and -35. Another way you could think about it too is, like with polynomials, if you had 8x minus 35x, you would just combine the coefficients and keep that x. Right? So what's 8 minus 35? That's -27. So 8 times the square root of 3 minus 35 times the square root of 3 is -27 times the square root of 3. That's the next term. Right? Just combining these like terms right here. Right? And the last one is -28 times, and this is a radical I can simplify. You can't simplify the square root of 3. Right? There are no perfect squares other than 1 that go into 3 evenly. So square root of 3 is already simplified, but square root of 9, that's 3. So the last term has factors of negative 28 and then, times 3. So I can multiply those, right? So we still have 10 here in the front. Then these two made the negative 27 minus 27 times the square root of 3. And then negative 28 times 3, right? That'd be negative, let's see, 3 times 20 is 60, 3 times 8 is 24. Add those up, that's negative 84. Now I'm almost done, right? I combine the like radicals, but now I have some other like terms as well, right? The 10 and the negative 84 are like terms, right? Those don't have anything attached to them. They're constants. So I'll put those together. 10 minus 84 is negative 74. So negative 74 for one term, and then we have this other term with the radical, right? Minus 27 times the square root of 3. And these are not like. This term has a square root of 3 attached to it. This term does not. So you cannot put these together. All right, that is as it's going to stay. You leave it alone. I'm done. All right. So all the radicals are simplified. All the like terms and like radicals are combined. I've multiplied and simplified. I am finished. And again, I like to check, right, just to make absolutely certain that the number I started with is indeed the number I finished with. Alright, so in parentheses I had in the beginning 2 minus 7 times the square root of 3. Alright, that's the first factor of that product. And then the second factor times, in parentheses here, 5 plus 4 times the square root of 3. And we're getting this number of negative 120.7653718 and so on. Now let's take a look at this last one. If I did everything correctly, all the multiplying and simplifying and combining like terms and like radicals, the number I have in the beginning should be the same as the number I have at the end. So what we have negative 74, then minus 27 times the square root of 3. And look, they are the same. They're both this negative 120.7653718 something. Wonderful. That's what you want to see. All right. Next example. This one might be a little trickier. All right. People tend to make this mistake. All right. Please don't, off to the side here, I'm going to tell you, don't do the following. You see 2 minus the square root of 5 squared, and then people like to distribute the powers. You don't distribute powers. The only time you distribute something is when you're multiplying, not raising to a power. So people very often say, oh, this is equal to 2 squared minus, the square root of 5 squared. So, what's 2 squared? 2 times 2 is 4. Minus the square root of 5 squared would be the square root of 5 times the square root of 5, which you can use the product property for. That's the square root of 25, which is 5. And then, 4 minus 5 is negative 1. This is wrong. This is very wrong. Check it out. All right. If you don't believe it, if you think, oh, this is right, I should be able to distribute the power. No, you can't distribute powers. But just double check it. In parentheses, 2 minus the square root of 5 squared. What's that equal to? Well, not negative 1. All right, it's 0.055728009. Not negative 1. So this is wrong. Do not distribute powers. In fact, in general, when you see a sum or a difference, a plus b or a minus b to say the nth power, this is not a to the nth plus b to the nth. You do not distribute powers. Do not distribute exponents. I can't emphasize that enough. I see that mistake made way too often. Alright, so going back to this, what is this actually equal to? Well, we saw here it's this 0.0572809 thing, let's see if I can multiply and simplify, get it to be written in a different way, and then double check. So remember what it means to square something. Now notice that this entire thing is in the parentheses underneath the 2. So 2 minus the square root of 5, that whole thing in parentheses is the base on this exponent of 2. Remember what that means. When you take a base and raise it to a whole number power, it means take that base, that 2 minus the square root of 5, and you're going to multiply by 2 factors of it. So there's 2 minus the square root of 5 times another 2 minus the square root of 5, right? You multiply it by itself. That's what it means to raise something to the second power, to square it. And now do you see how the problem becomes just like my last example, where I'm multiplying 2 expressions that have 2 terms. So we're going to do a lot of distributing. So pick one of them, I'll pick this one. I'm going to distribute the 2 first to the other expression, and then I'm going to distribute the negative square root of 5. Don't forget negative is part of the term. All right, let's see what 4 terms we get here, because I got to see 4 arrows. All right, so the first term, right, I have 2 times 2, 4. Then a positive 2 times negative square root of 5, so that's going to be negative, right? Positive times negative. And then you just have 2 times the square root of 5, those factors in that term, 2 times the square root of 5. You can't put those together. Don't make that the square root of 10, right? One's a square root and one is not. Can't use the product rule there, product property. Okay, so that's what I get after distributing the 2. So I'm done with the 2. I move over to the negative square root of 5 and do the same thing. Alright, so negative square root of 5 times positive 2, that would be negative, right? Negative times a positive would be negative. And then again, I have the same factors. I have the square root of 5 times 2, or 2 times the square root of 5. And like I've done before, usually the non-radical is written before the radical factor. Alright, and then the last distributing I need to do, I have negative square root of 5 times negative square root of 5. So negative times negative, that will be positive. And we have our factors of square root of 5 and square root of 5. Square root of 5 times square root of 5, those are both square roots. I can use that product property. Square root of 5 times square root of 5 is square root of 25. Alright, and then we combine some like radicals and simplify simplify radicals, combine like radicals, combine like terms. First term is still 4. These two, the negative 2 times the square root of 5 plus negative 2 times the square root of 5, they have like radicals, both square root of 5. So combine them. Negative 2 and negative 2 make negative 4 times the square root of 5. Right? That's these two put together. And then plus the square root of 25 is something we should know is 5, right? 5 squared is 25. And then the only other like terms now are the 4 and the 5, the constants. Right? Positive 4, positive 5, when added, when combined, make positive 9. So I have 9, and then you have this other term of minus 4 times the square root of 5. And again, these two terms, don't subtract the 9 and the 4. Don't make this 5 root 5. These are not like. And again, remember your order of operations too. The multiplication would happen before the subtraction. So you cannot put these 9 and 4 together, right? This 9 does not have a square root attached to it. The 4 does. You don't put them together. This is as simple as that gets. All right, now let's test it. Let's check it out. Make sure it's correct. So I already put in the 2 minus 5 quantity squared. That's this 0.055728809 and so on. Now let me put in this number here at the end. Hopefully the number at the end is the same as the number I started with. Should be. So that's 9 minus 4 times the square root of 5. And look at that. They are indeed the same number. All right. So not negative 1. Don't distribute powers, please. It's a big pet peeve of mine. I really hate it when people do it. Alright, next example. I've just got 2 more. Here's another one where please do not distribute the powers. This is a difference. This isn't a product. All right, this is subtraction, not multiplication. So don't distribute the powers. It's wrong. All right. So think about what this means. All right. This entire expression in the parentheses is the base under that exponent of 2. So what does that mean? You take that base and multiply it by itself. So this is the square root of 7 minus 3 times the square root of 2 multiplied by itself, right? What it means to square something. Square root of 7 minus 3 times the square root of 2. And then just like the last two examples, I have two expressions with two terms. So I pick one and I take each term from one of them, distribute to the other, and then we'll combine all the like stuff at the end. So first I'll distribute the square root of 7. All right, see what we get there. All right, so the first, you got the square root of 7 times the square root of 7. They're both square roots. So I can use the product property. That's the square root of 49. The square root of 7 times 7. I know that's just 7. But I'm writing the square root of 49. I'm using the product property here. Alright, then we have the square root of 7 times negative 3 times the square root of 2. So a positive times a negative. The next term will be negative. And my factors are the square root of 7 times 3 times the square root of 2. Well, the 3 can't be multiplied by any of those, because these two are in square roots, the square root of 7 and the square root of 2, but the 3 is not. So I have 3 on its own as its own factor, but then you have times the square root of 2 and the square root of 7. Well, you can multiply those. You can use the product property for those. They're both square roots. Square root of 2 times square root of 7 is the square root of 14. Right, the square root of 2 times 7. Wonderful. All right, so that's done with that. And I move over. I'm done with the square root of 7. Now I move over to the negative 3 square root of 2 and distribute that to the other expression. All right. Negative 3 times the square root of 2 times the square root of 7. Well, that's a negative times a positive, so the next term will be negative. And I have the same factors as this other one here. I have the 3, which won't go with anything because the other two are square roots. So I have the 3 as a factor, and then that square root of 2 times the square root of 7 make again the square root of 14. I can use the product property there. All right. And then lastly, I have negative 3 times the square root of 2 times negative 3 times the square root of 2 again. That's a negative times a negative, so the last term will be positive. I do have a 3 times a 3 that I can multiply together. Those factors are 3. 3 times 3 is 9. And the other factors are square root of 2 and square root of 2 that make the square root of 2 times 2 the square root of 4. I can use the product property with those. All right. Now let's do some simplifying. All right. The square root of 49 is 7. Square root of 14 cannot be simplified, right? There's no perfect square other than 1 that goes into 14 evenly. So these are both going to stay the way they are, the square root of 14, but look at them, they're like. These two terms have like radicals. Both have the square root of 14. So you just combine them, combine the numerical coefficients. Negative 3 of it minus 3 of it would make negative 6 of that, right? So I'd have negative 6 times the square root of 14. Again, you could also think of factoring the square root of 14 out of these two terms and then combining the negative 3 and negative 3 left over. So these two terms make negative 6 times the square root of 14. And the last term is plus 9 times the square root of 4. But square root of 4 is 2. So that last term is 9 times 2. So we have 7 for the first term, minus 6 times the square root of 14 for the second term, plus, and this last term is 18, right? 9 times 2 is 18. And the only things that I can put together that are left are the constants, the 7 and the 18. Positive 7 plus 18, that's positive 25 for one term then. And the only other term left is this one with the radical, the negative 6 times the square root of 14. And that's it. Leave it this way. Again, do not subtract 25 and 6. Remember the order of operations. the 6 and the square root of 14 would be multiplied first, and then you'd subtract, right? So this is the way it's going to stay. This has a root. This does not have a root. They don't go together. They're not like radicals. That's as simple as it gets. 25 minus 6 times the square root of 14. All right, and once again, I would like to check this. All right. So is the number I started with actually equal to the number I finished with? It better be. So let's clear this out. So in the first one is in parentheses, right? The square root of 7, pardon me, the square root of 7 minus 3 times the square root of 2, all of that to the second power. All right, it gives me 2.5500556679, blah, 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 blah. All right, now look at what we got at the end. 25 minus 6 times the square root of 14. Oops. Sorry. 25 minus 6 times the square root of 14. There we go. And look at that. It is indeed the same number, 2.5500556679, so on, so on, so on. All right. Wonderful. All right, so I have one final example where I'm doing the same thing again and again. All right. We're distributing, we're simplifying radicals, we're combining like terms and like radicals, and then of course checking our result. Is it actually equal to the number I started with? All right, so here I have no squares or anything. So I have, a two-term expression multiplied by another two-term expression again. Square root of 3 plus the square root of 2 multiplied by the square root of 3 minus the square root of 2. Now these, notice how they look exactly the same except for the sign in the middle. And these are called conjugates. You may have seen this word before. Conjugates are, a plus b and a minus b. Those would be considered conjugates. And the thing about conjugates, when you multiply them, you end up with a difference of squares. You're going to see a squared minus b squared showing up here. When you multiply two binomial conjugates, you end up with a difference of squares, a difference of two squares. Okay, so hopefully that might ring a bell. I probably brought that up in another video on multiplying polynomials or even factoring. This definitely came up in a video I put up prior, factoring the difference of two squares, if you want to look that up. Where if you start off with a difference of two squares, you can factor it to a product of binomial conjugates. So the product of these conjugates, a plus b, a minus b, or a minus b times a plus b, right, whatever. So if this is correct, we could do a little shortcut here. I'll do it both ways. You see how this statement here, a plus b times a minus b, that's exactly like this, where the square root of 3 is a, right? Square root of 3 is a, and the square root of 2 is b. So if I recognize these as conjugates, we can jump to the end and say, oh, this is going to be the square root of 3 squared, a squared, minus, and then the square root of 2 squared, right, b squared. And what is the square root of 3 squared? That's the square root of 3 times the square root of 3, which would be the square root of 9, or just 3, minus. And then what is the square root of 2 squared? That'd be the square root of 4, which is 2. And what I end up with here is just the number 1. This product will be equal to 1. Again, that's a shortcut way. If you recognize that this is a product of conjugates, a plus b, a minus b, you can jump to the end and say, oh, the resulting product will be just a difference of their squares. But, say you didn't recognize that. So here's the long way, right? Again, pick one of them, and then I'm going to distribute, right? Take the square root of 3, I'm going to distribute that to the other expression. All right, so we're getting square root of 3 times the square root of 3, right? The square root of 9. I can use the product property for those. then the square root of 3 times, negative square root of 2. So it'll be negative, right? Positive times negative. And then the square root of 3 times square root of 2, I can use the product property again. That's the square root of 3 times 2, the square root of 6. All right, so now I'm done with the square root of 3. And I move over to the positive square root of 2 and distribute that to the other expression. So I have positive square root of 2 times positive square root of 3. That'll be a positive term. And they're both square roots, so I can use that product property. They're both real numbers, square roots of positive numbers. They're both real. I can use the product property. Square root of 2 times square root of 3 is again square root of 6. And then I have positive square root of 2 times negative square root of 2. So positive times negative, the result will be a negative term. And then you have two square roots again. Square root of 2 times square root of 2 is square root of 4, 2 times 2. And you see how these two terms in the middle will disappear, right? You have negative square root of 6 plus the square root of 6. That makes 0. And so all I'm left with is the square root of 9, which is 3, then minus the square root of 4, which is 2, and I get the number 1. Right? As I mentioned earlier when I did the little shortcut, right? Because you can hopefully you recognize, hey, these are two conjugate pairs, right? A plus b, a minus b. The result will be a difference of squares. But either way is fine. It doesn't matter if you do the shortcut or not. You end up with the same value of 1 both ways. And again, just to check real quick on my calculator, is this number I started with actually equal to 1? All right, so I have this in parentheses, the square root of 3 plus the square root of 2 times, and then in parentheses, the square root of 3 minus the square root of 2. And we're getting 1. So yes, this is true, what I have written. Looks like it. Okay. Wonderful. Alright, so lots of stuff similar to polynomials here, right? Do all sorts of distributing and then combining like terms, like radicals, and of course you have to remember how to simplify your radicals as well. That's another video you can look up, or another section of your book you can read. All right, great. And of course, double check your answers, always. All right, as I like to say at the end of these videos, try the best you can to learn the material on your own before you go looking for help. I find that people who take the time and the effort to learn things on their own tend to remember them for longer and remember it better and are more proud of it. Gives them a confidence boost or whatever. So, of course, read the material. All right, read through the author's examples. Perhaps even work on the solutions to the author's examples before you see how the author did it. And then compare your work with the author's and see if you can learn from some mistakes there. Obviously, work on loads of exercises, practice problems. Look up solutions to those whenever they're made available so you can check yourself, keep track of your progress, see how you're doing. And don't give up on a problem or an exercise after one attempt. Don't give up so easily. There are very often mathematics, there's several ways to approach a problem that'll work. But if after several approaches at a problem or several problems, you're still not understanding how to do them, how to get through them, maybe you should read the material again. Maybe even a third time, more slowly, more deliberately. Take good notes. Because if you've been working on some problems, chances are you have a better idea as to what the author wants from you, what the author's asking of you. So then when you read again, or even a third time, you'll know better what to look for from the text. Maybe you'll even see some things that you didn't see the first time that'll shine some light on the subject, make some things click in your head that didn't click before, and make the problems that much easier to work on. But if after several read-throughs of the material and several attempts at problems, you're still not getting it, it's not a sign of weakness whatsoever to go out looking for help. That is what other people are there for, to help you. So ask a teacher, a tutor, a friend, someone else in your class who knows the material well and is willing to help. Look for supplemental materials online. There's loads of it out there. Look for videos on the subject. There's tons of those too. Videos like this one, or plenty of other ones out there better than this one. I assure you they're out there and they're easy to find. But just stay persistent. Keep at it. Keep practicing. Don't give up. And I think above all, and I think the hardest thing, is to try to stay positive about the subject. Believe in yourself. Don't be so defeatist, even when you're struggling. The times that you're struggling and failing at something are the times when you can learn the most. So just keep at it, stay persistent, keep practicing. Try to stay positive, have a positive outlook about the subject. I know it's easier said than done. And just don't give up. And I just know you'll get it eventually. Thank you very much for watching.